Hi, so this is our electrochemistry chapter. My name's Hope.
My name's Matthew.
My name is Mariangela.
My name's Alyssa.
So the first thing we're going to talk about is lightning and batteries itself. So electrons flow away from negative charge towards positive charge. A driving force for lightning and batteries are both the same. A battery is composed of substances that are separated. So at the end of one battery, there's a positive charge, while at the end develops a negative charge. Electrons flow through like an electron current. The movement of electrons in batteries constitute an electrical current, like I said. Electricity is a fundamental form of energy. We have what's called an oxidation reduction. So you have cathodes, which are reduction occurring, and then you have anodes, which are oxidation occurring. For example, anode is negative ions, cathode is positive ions. Sulfur is an oxidation agent, for example, and carbon is a reduction agent. When you look at C plus 2S yields to CS2. What else do we have? Okay, so we have what's called oxidation half and reduction half. In that case, we have what's called half reaction. So the oxidation half reaction is electrons as products, and the reduction half reaction is electrons as reactants. You also have what's called an electrical current. So an electrical current is the amount of electric charge that passes through one given point at a given time. In this case, an example that we used in lab was the salt bridge. We also have the current, which is in AMP. 1 AMP is equal to 6.242 times 10 to the 18th electrons per second. 1 A current is equal to 1 coulomb. So we also have potential differences, which are the difference in potential energy between the reactant and product. Our standard EMF is called the E cell. What else do you have? Okay, so a difference between the volts and amps is the volts is a unit that qualifies the differences in electron potential energy, and the amp quantifies the flow of electrical currents. And then we go into the next section, which is about half cells.
Each cell has 2 electrodes, the anode where the oxidation happens and the cathode where reduction happens. And to keep the reaction going, they're connected by the salt bridge. Sometimes the electrodes are made of the actual metal being oxidized or reduced, but if it involves ions or gases instead of solid metals, the cell uses electrodes like platinum or graphite, which don't react. They just provide a surface for the electrons to transfer. And then we also learned how to write the cell notation, which is the shorthand way of describing a cell. So the oxidation side is written on the left, the reduction side is written on the right, and the salt bridge is shown with a double line. And then we talked about the standard reduction potentials. Since we can't measure the absolute tendency of reactions to gain electrons, everything is compared to the standard hydrogen electrodes, which is 0 volts. And then a positive reduction potential means that the substance is more likely to be reduced, while a negative value means it's more likely to be oxidized. And then using these values, we can predict the direction electrons flow when the 2 half cells are connected. So they always move from the half reaction that prefers oxidization to the one that prefers reduction. And then you can find the cell voltage by subtracting the anode potential from the cathode potential.
Then we also talked about how to calculate cell potential under standard condition, which is E cell equal to E cathode minus E anode. We also talked about the tendency from the table of standard reduction potential. We said that higher on the table of standard reduction potential, the stronger tendency for the reactant to be reduced. And then lower on the table, it said that the product will be oxidized. We also talked about predicting spontaneity of redox reaction. We said that any reduction reaction is spontaneous when paired with the reverse of any of the reaction listed. We also had some question when we said that when a solution contains two product, is it gonna be oxidized, or like which agent is going to oxidize it? We also talked about predicting whether a metal will dissolve an acid. We said that metal whose reduction half reaction are listed, they dissolve in acid, and then the metal that are not listed or not dissolved in acid. Then we also talked about E cell, delta G and K. We said that for a spontaneous reaction, one that proceed in the forward direction with the chemical and their standard state, we said that delta G is smaller than 0, so it's negative. When E cell is greater than 0, it's positive, and then K is greater than 1.
Finally, we learned about the Nernst equation, which is like an equation that helps determine the cell potential at like non-standard conditions. And then we learned the voltage for dry cell batteries, alkaline dry cell batteries, lead storage batteries, and lithium ion batteries. And finally, we learned about electrolysis. And when electrolysis reactions require more voltage than E cell equation predicts, then that's called overcharging. Over voltage. Oops. But yeah, that's it.
And that's
Thank you.
our
And that's
chapter.
our chapter.
Yeah.